In this video, I'm going to show you how you can make yourself a 3D cube using linear equations on Desmos. I have a 3D quick start that you can find in the description, so go ahead and right click on it and open it in a new tab so that you can follow along. Now in this pack you will find that I have a folder for all the setup stuff. This has everything you need to plot in 3D on a 2D graph. And to get started, let's make ourselves a new folder, and I want to call it the default cube. And the cube dimension we're going to be going for is a simple 1 by 1 by 1. And to start plotting, you very simply start using the order pairs notation. So you use the x sub 2 function that came to setup pack, and you put the 3D point in here that you want to convert from a 3D to 2D. And to make this easier to follow along, I'm going to go ahead and plot all 8 vertices on this cube, and I'll also rotate it to show you the entire cube. So this should not take long, so I'm going to go ahead and show you how it's done. And right, so I want this to be moved back on the z-axis. So the z-axis is actually what's coming directly at you. And so what you should see here is now it's the horizontal axis, so I want to rotate it this way. So you already see there's a bit of 3D happening here. And you rotate it a bit on the y-axis as well. That would make it easier to see. And just 4 more points. Let me collapse this. Alright, this should be moved down by 1. And we'll go ahead and move this over by 1. And now we're missing the 2 in the front. That's fine. We can just simply copy what was our last 2 points, and that will bring them both to the front. Alright, so the back four consists of these 2 points in purple and this green point and this black point down here. And now we need to copy this blue point down here. There we go. And then we need to grab this red point and move that down. Alright. So I plotted the points of a cube so you can see what we're trying to do here. We're trying to draw a line between these 2 points. If all you came for is just to draw lines and not do anything with them, there's another video for that one. Much easier to follow. I recommend that. I will have a link for that in the description. But the motivation behind drawing lines is so that we can apply inequalities to color them, which will be done in a future video. So that is the point of this exercise. Alright, so now that we know which 8 points we're trying to do, we also know where to draw lines from. So suppose we want to, so I'll just, for example, draw a line from this blue point that I have my cursor over to this red point over here. And we know what these 2 points are. It's these 2 first points here. and we do that with a linear equation, and that would be with the point slope formula, which if you remember, it's y minus y1 is equal to m times x minus x1. Of course, we want this to be in a linear form, so we want to add y1 to the other side. Alright, now what is m? Well, m is our slope here, and to find the slope, we simply do a delta y over delta x. So I'll grab this point here. Order is important if you're planning to... It's important where you have to be consistent. So you could have picked the second point first, but I'm just going to pick this first point first. So we'll subtract... Oh. Right. So get your delta y by subtracting. I got a neat trick for you, and if you highlight this section that you want to be divided by, and then you press your division symbol on your keyboard, it'll draw a division line underneath. And because as I picked this red point first, I have to now use its x value first. Alright, so now we have the slope, and now we need to know what x1, y1 is. Doesn't matter which one we choose as long as it's coming from the same point. So this is our x1 and this is our y1. Alright, so as you can see, I have drawn a line through it. And to make it a bit easier to follow, rather than using a solid line, I'm going to switch over to a dashed line here. Alright, and next step is to actually bound this line between this point and this point here. And because we know that this blue point has a smaller x value, I'm going to choose this first. I'm going to use set notation. We're going to say this x value is less than x, and is also going to be less than this red point here. If you accidentally make a mistake, Control Z will just bring it back. Alright. As you can see, I bound this point between the blue point and the red point. If you were thinking ahead, you would know that if I rotate this cube right around 180 degrees, this inequality will fail. Because now what we've done by rotating it halfway around is now this x value would have now been less than this value here, and therefore the line would not show. The good news is there's an easy way to address that, and that is with a comma here. And what this comma says is which is saying or this x value can be less than x and also be less than or equal to this value here. If you switch the two around and you put the comma there, it would say if at least one of these conditions are satisfied, then you will draw a line. Does that make sense? So we wrote a lot in one line, and of course copy and paste is almost always our friend. It doesn't work all the time, but if done correctly, you will save yourself a bunch. I'll do one more pair of points, and then I'll jump to the end on what you should hopefully have. Alright, so now my objective is to draw a point. I'll give you a weird case. Let's do these two red points here. Probably not the best example. Let's do this blue point and black point down here just so you can see which two I'm talking about. And it's this one here. And if you don't know which black point it is, if you click into here, you can see that actually this point got highlighted. So instead, we want this one over here, which actually made this point a bit bigger. I think I know which two we're using. Alright, I'm going to show this green line again. That's what we're trying to draw. And this line is wrong because it was a direct copy and paste of the line above here. And I like choosing the Y first. And then, as we established, this is our second Y point. Then we also want our delta X. Alright, and then we also want an X and a Y point. I want to pick the convenient one that's closest to the equation, and that is this point here. Grab this X value, and then we'll grab this Y value down here. Come on. Alright, and we also want to bound between the X values. So to make it a bit easier for us to see, let me address one thing first. I know you're all looking at it. Why do we not see a line going up and down here? Well, the thing is that lines with undefined slopes will not show, and the way around it, as far as I'm aware, is I know this is the z-axis coming right towards us. So now we spin it a little bit. You can see this line comes out. Alright. And now we're going to be using these 2 points down here. There we go, and I'll make this a dashed line just so you can see it. So, repeat the process for the other points, and I will see you shortly. Yeah, I'm not done yet, but I do want to drop a tip over to you. And that is if you're getting tired of always picking out which points you're connecting to, you can always pick out a line. Say, I know I want to draw a line between these 2 points, and this line is exactly parallel with this one. Only difference is that at anywhere I see a negative y, I want to make a positive. That's fine. And what you can do is click into here, Control A, and then Control A, select everything, Control C to copy, and Control V to make a new one. That is definitely expected. And the difference, as I mentioned before, is that all the Y values are positive. So anywhere you see a negative sign, just straight up delete them. And just like that, you just drew yourself another line, and you didn't have to go through the agony of picking out which line you want to draw. I'll do a few more. Let's say, let's grab this line down here. Same process. Difference is that at all the y values go from negative to positive. So paste that in there. Press home to go to the beginning. That didn't work. That's fine. These equations are long because we're trying to impose a lot of constraints. I suppose that was part of the cause by having a function to make 3D points instead of simple points. But if you want 3D graphs, gotta do what you gotta do to work with a 2D plane. And this is not far from done at all. Don't worry about it. And differences now is that I want to move this back, and that's along the z-axis. So anywhere I see a positive z value, I need to make them negative. If this process isn't making any sense to you, you may always pause it or ask in the comments. There's no shame asking for help. This is not a particularly easy thing to do, especially since all these ideas are clumped together in one video. I just drew a line over here. I want to move it back, so the z-axis needs to go from positive to negative. And something I like to do before we celebrate is, I mentioned earlier that by having two inequality constraints, that should allow this line to show if we rotate it halfway around. So we are 5 degrees rotated on the z-axis. Oh gosh, the anticipation. Let's make this orange, so we know which line we're trying to rotate, or that we're trying to watch on. Okay, so I rotated halfway around this way. That should still be fine, because now what's happened is these points are now opposite sides, and yet this line is still showing. I meant to rotate halfway around the horizontal axis. And what is that? So we were actually 21 degrees, so if we rotate it halfway around, that should get us to 201. Okay, so not bad. A few mistakes. Alright, so at least now, by testing this out, so we now know that this line is supposed to go from this purple dot to this black dot here is now functioning as expected. And that's because I forgot to draw it. How silly is that? So what's the difference between the green line and that other line is that all the x values should go from positive to negative, right? highlight this, and that looks wrong. Everything else looks right. So anywhere we see a negative, everywhere we see a positive x, that should be negative. Alright, now, can we celebrate? We'll find out by rotating this 180 degrees around. Not bad at all. So, if you have typos, go debug and fix them. Otherwise, I certainly hope they have a nice cube you can enjoy. And as a final touch, you can make these lines however you like. And if you found videos like this helpful, I know it was long, but there was a lot to talk about. And if you enjoyed it, please leave a like button. And if you want to see more videos like this, there will definitely be more videos like this. In the next video, we will actually be coloring. That's the big motivation behind all this pain, is so that we can actually color these lines. So, looking forward to that. Hit the subscribe button so you don't miss out on it. And in the meantime, please stay safe and enjoy your Labor Day weekend.